All right. Okay. So make sure so we can actually see better here. All right, you guys. Okay, so secondary math 1. Basically, the whole year's focus is on linear equations, linear functions. Okay, linear equations or functions are when you graph them and it forms a straight line, right? That's why we call them linear. Okay, a lot of what we worked with in secondary 1 and 2 were linear equations written in slope-intercept form. So let's go ahead and remind ourselves what slope-intercept form looks like. Okay, so remember, slope-intercept form is always written as, you have your y equals, y's all by itself on the one side, hopefully it's coming back to you now. Then we have an m in front of the x plus b. Y equals mx plus b. Okay, well, who remembers what m stands for? Remember, it's either the slope or the y-intercept. It's in slope-intercept form. What's always in front of the x? You remember, it's either the slope or the y-intercept. Throw out a guess. Yeah, Kaylee.
The y-intercept?
Well, not the y-intercept, it's the slope. Remember, the slope is always right in front of the x. Whatever number, fraction is right in front of the x, that is your slope. Okay, so if that's our slope, then whatever number is on the end of your equation that doesn't have the x attached has to be the what? What intercept does that have to be? Nice. Y-intercept. Okay, a little refresher. So for numbers 1 through 4, it's asking us to write the slope-intercept form of the equation of each line given the slope and the y-intercept. Okay, so we notice that it gives us a slope and it gives us a y-intercept. We just need to place it where it goes in the equation. Okay, so we always start with y equals. Okay, you can put y equals for each one of these guys. We know it's always going to start with that. Y equals, y equals, y equals. Okay, so then let's look at number 1. So what goes in front of the x, the slope or the y-intercept? Slope. Okay, so we have a slope of -4. What always has to be attached to the slope? X, good job. So do we have -4x? And then we have a y-intercept of +5. Okay, easy peasy, plus 5 goes on the end. Oh, Mrs. Campbell, this is like first grade stuff. Okay, try 2, 3, and 4 on your own. I'll freeze it, and then we'll compare. Okay, try writing all those equations on your own, and I'll do the same, and then we'll see what answers we get. Okay? Okay, take like 10 more seconds. I hear some pencils dropping with confidence. Love it. 5, 4, 3, 2, and 1. All right. Compare your answers to mine. So for number 2, gives me a slope of +8, which goes in front of my x. Then it gives me a y-intercept of -5, so where we put -5 on the end. Okay, number 3, slope of 5/3. Don't freak out that it's a fraction. Still goes right in front of my x. +5 for my y-intercept, so +5. Number 4, slope -1/2 x, and then y-intercept of +1. Okay, raise your hand. How'd we do? 5, I got all 3 of those good. Doing awesome. Anywhere in the middle? Or maybe missed 1 or 2? Sweet. Okay, so let's look at numbers 5 through 8. Now, it's asking us, write the slope-intercept form of the equation of the line. Okay, so again, we're looking for that slope-intercept form that we identified at the top of our paper. But are these guys written in slope-intercept form? Do we see y equals on any of them? Nope. Y needs to be all by itself. We see a lot of stuff on the same side as my y. Okay, so what we're going to actually do, if you want to put a star, is we're solving for y. Meaning we're trying to get y by itself. We know how to solve an equation. You guys are awesome at that. So we're just trying to get y to be the only thing on that side of the equal sign. Okay, so let's go ahead and look at number 5. Okay, so look at the side with your y. That side right there. We have a few things we need to move. We have a 4x we need to move, and then a -3 that's attached to that y. Remember, we work from the outside in, closest to what we want by itself. So which piece do I need to move first? The 4x or the -3? What do you guys think? Which is farthest from my y, Kaylee? Love it. We need to move that 4x first. Okay? So look at the whole piece, whole 4x. What's the opposite of positive 4x? Negative 4x. So we're going to move that whole piece to that side. Okay? It's not on that side anymore. It is now moved to the other side. So now we have left -3y, left on that side, equals -33 that was already over there, and then a -4x once we moved it. Cool, cool. Is my y by itself yet? Nope, not yet. Okay, what is still attached to my y? -3. Okay, now be careful. This is not saying y -3. This is saying -3 times y. So how do I get rid of times by -3, Kaylee? Beautiful. Divide by -3. That gets rid of it. Divide by -3. But wait. What do I need to do with that -3? Do I just divide it by the -33? Just one of those terms I have to divide by -3? Nice, Callie. You have to divide everything on that side by -3. Everything gets divided. Okay, so y's all by itself now. Now we just need to make this side a little prettier. Okay, so let's look at our first piece. If you want to use a calculator, you're more than welcome to. What is -33 divided by -3? Kaylee?
11.
Positive 11?
Yes.
Yep, you got it. So we get positive 11. Now look at my last piece. Can I reduce -4/3 or -4 divided by -3? Can I make that fraction smaller? Nope. But tell me, what's a negative divided by a negative? Ah, so we just got to change that to a positive. Stays 4/3 x. Now, this guy is written in slope-intercept form. Usually we'd put the guy with the x first, but that's okay. Still written the same way. Does that kind of make sense? Boom, slope-intercept form. Okay, let's do it again for number 6. I need my y to be all by itself, so look at the side with my y. What do I need to move first? Just the 2? The 2x, that whole piece. How do I move a positive 2x? Kelly? Negative 2x. Love it. Negative 2x. That gets rid of it on that side. Subtract it from both sides. So I have left positive y equals 1 that was already over there. And negative 2x. Anything else we need to do to get y by itself?
No.
No, y's by itself, right? Boom. Easy peasy. People on your phones, you're being rude. Put them away while I'm talking. Okay, so we're all done. Y's all by itself. Okay, let's just do one of the next two. Do you guys want to do 7 or do you want to do 8? Which one looks harder? Which one do you want to do? 8? Okay, let's do 8. We'll skip 7. All right. So we want y to be by itself. So look at the side with your y. Okay, just that side. What piece do I need to move first? Farthest from my y. Isaac? The 5x, the whole piece. What's the opposite of a positive 5x? Good job. Subtract 5x from both sides. Okay, so I have left on this side negative 4y equals negative 24 that was already over there and the negative 5x that we moved. Okay. Last step, because my y is not by itself yet. How do I get rid of that negative 4? Careful. It's not being subtracted. Good job, Bella. Yep. What she means is we are going to divide. Put it under, divide, divide. Love it. Okay, so my y's all by itself. Let's just make this side a little prettier. Okay, reduce these fractions if we can. First piece, you can use a calculator if you want. What is negative 24 divided by negative 4? Isaac? Very close. 6. There we go. Positive 6 for my first piece. Now, my second piece. Can I reduce 5 over 4? 5/4. But negative divided by a negative turns into a? Nice. So it changes to a positive 5 over 4x. And there we go. Slope-intercept form. Remember, whenever you see slope-intercept form, it means it wants the y all by itself. Okay, give me a fist of 5 on rewriting it in slope-intercept form. I can move everything so y is all by itself. How are we feeling? Anywhere in the middle, it's like day 1 of notes, so that's totally fine if you're somewhere in the middle. Beautiful. Okay. For numbers 9 and 10, we love graphing in this class. Welcome to graphing. That's like what we're going to do a lot of for secondary 3. Okay, so it wants us to graph these guys. Now answer me, are these in slope-intercept form? Gabe, say it with confidence.
Yes.
Yes. Why, Gabe? Because what's all by itself on one side?
The y.
The y is all by itself on one side. So it is in slope-intercept form. We love graphing in slope-intercept form because it tells us 2 things. Our slope and our y-intercept. Okay, somebody help me identify my slope. What is my slope for this guy going to be? Kaylee.
Negative 2/3.
Love it. Why'd you get negative 2/3?
Next to the x.
Beautiful. My slope is negative 2/3 because it's right in front of the x. What's my y-intercept then? Positive 4. Okay. Who remembers from last year? What's our starting point? The slope or the y-intercept? We have to start with one of them, Isaac. It's the y-intercept, okay? So remember, put a star. You always start with the y-intercept. That's a point, okay? In this case, it's a point at positive 4 on our y-axis. This guy right here. So put point at positive 4. Boom, there's your y-intercept. Now, how in the world do we use the slope to count to our next point? Who remembers those 2 little words? They start with R's. Something over something. Isaac? Oh, so good. I'm such a good teacher. Look at you guys. Rise over run. Okay, so that's how we're going to use those numbers, that fraction, to count to our next point. Okay, so let's just say that that's a negative 2, right? It's a negative slope, meaning it has to go down and to the right. So we're going to rise 2, in this case negative 2, down 2, and run 1, 2, 3. Okay. Connect those 2 points, arrows at the end, and there you go. You're done. Okay, let's make that note on our notes. Okay, remember that a negative slope, which this was, a negative 2/3, negative slopes always have to go down to the right. Okay, just like you read a sentence from left to right, you read a graph from left to right. So if we go from left to right, we see our line is going down, negative slope. All right. Thank you. Careful, it's a big desk.
There's a desk right there.
All right. Okay, so is number 10 in slope-intercept form? Is y all by itself?
Yeah.
Yes, it is. We love that because we can identify slope and y-intercept. Okay, somebody help me out. Raise your hand and tell me what's my slope. Callie.
200.
Love it. 2 fits, right? The x tells us where it's at. Slope is 2 fits, or 2/5. What is my y-intercept? Kaylee. -3. Which one is our starting point? The slope or the y-intercept? Gabe.
The y-intercept.
The y-intercept. Okay, so remember we always start with our y-intercept. So you're going to find -3 on your y-axis. Boom. There's your starting point. Your first point goes at -3. Okay, now we're going to use rise over run. Is this slope positive or negative?
Positive.
Positive, which means our line should go up and to the right. So we're going to rise 2, 1, 2. And we're going to run 5. 1, 2, 3, 4, 5. 2 points is all you need for a straight line. So connect those 2 points. Arrows at the end because this line technically goes on forever. And there we go. Okay, just like we made a note for a negative slope, let's make a note for a positive slope. Positive slopes go up to the right. All right, show me a fist of 5 on graphing and slope-intercept form. How you feeling? I can take a test right now, get 100%, anywhere in the middle. Nice, love it, guys. Okay, here comes the fun stuff. This is like secondary math 3 stuff, the new stuff. Okay, evaluate each function. Okay, these are all linear functions because you'll notice that none of them have a squared attached. There's no exponents attached to these guys. They're all linears. Okay, so what it means when it says to evaluate this guy, see how it starts with h of n? Okay, so we have our variable of n. But then it says find h of 10. So meaning find the function if you were to plug 10 in where your n used to be. So it gives us a function with a variable, right? But then it's telling us what to plug in for that variable. So let's make that note. All we're doing is plugging in what it tells us to plug in. Okay, so for this guy, we have our original function. There was our n. We're going to take that 10 and plug it in where our n goes. And it's going to look like this. So we had 4 times n. Well, we plugged in a 10 for our n. Minus 3. 4 times 10, which we plugged in, minus 3. Yeah, Connor.
37?
You what? How'd you get 37, Connor?
Oh, 4 times 10 is 40, with the -3, it's basically -3, so.
Beautiful. Okay, so from here, it's just following the order of operations. We have to multiply before we can subtract. 4 times 10 is what? 40. 40 minus 3 is what? What's my final answer, Connor?
37.
37. Love it. So all you're doing here is plugging it in where it tells you to, and then solving, evaluating. Okay, so let's do that again. So we have a function, that's what that little f means, a function of x. Okay, so here's our x in our function. What are we plugging in to that x spot? What is it?
-9.
-9. Beautiful, Braden. So we're going to take that -9, and it wants us to plug that in where that x was. Okay, so now it looks like 3 times -9 minus 2. Okay, we got to do the order of operations, so you have to multiply before you subtract. Help me out. What's 3 times -9? Isaac?
-27.
Love it. What's -27? Subtract 2 more. Kaylee?
-29.
Love it. Woo. Not too bad, right? Not too bad. Okay, number 13. We have a function of x. So here's where our variable is. What does it want us to plug into the x spot?
6.
Positive 6. Booyah, right there. Okay, let's figure out what that is. So now I have -3 times by positive 6, and then plus 5. What is -3 times positive 6? What are we going to get? -3 times a positive 6. Connor?
-18.
-18, love it. Last step, what is -18 plus 5? So you're in the negatives, but you're getting more positive. Okay, people in the back on their phones, like, I can see that. Yeah, Connor.
13.
What was it?
-13.
-13. You're getting less negative here. Okay, so we get -13. Great job, Connor. Okay. Think you could try one on your own? Want to do one more together? Let's do it. Okay. 14. Does it matter what letter they choose, guys? For the variable? Does it matter? Sometimes it's x's, sometimes it's n's. No, it's still a variable. So we have our variable, which in this case is a. What does it want us to plug into that a spot? Kaylee?
-6.
-6. Booyah. Okay, so we're going to take 2 times -6 that we plugged into the a spot and add 3. Okay, we got to multiply before we add. What is 2 times -6? Kaylee?
-12.
Love it. Last step, what is -12 plus 3? We're in the negatives. We're getting 3 positive, more positive. -12 plus 3. It's going to give me, Callie. Close. That would be more negative. We're getting less. Ooh, very close.
-9.
-9. Boom. Final answer, -9. Okay, I want you guys to try 15 and 16 on your own. I'll do them as well, and then we'll compare answers, and boom, I'll set you free to work on your assignment. Question, Callie.
Never mind.
Okay, cool. Try number 15 and 16 on your own. I'll freeze it, and then we'll compare answers. Let's take like 2 minutes if you need it.